fast APIs using single-class microservices. Excellent. Thanks so much.
When was the last time that you did this? This happened at the summit as well, the AWS summit. Was anybody there? Oh, no. Anyway, this is people queuing for a movie. Now, it could be a movie, it could be an event, it could be a museum, it could be an art gallery, it really could be anything. And this sucks. Hold on, we all hit it. It's not even raining in this photograph, but generally speaking it is. And you've got this massive queue. You've been standing in it maybe 20 minutes, half an hour, and there's one little alcohol booth up at the front, and everyone's queuing to get to it. And it just takes a while. It just sucks. It's just hard to do. And this movie's 1999. You know? I mean, this is ages ago. This is nearly 17 years ago now. This is 2016. We all have mobile phones. We've probably bought the tickets online for whatever it is we're going to do. Why don't we have 10 little entrances into this particular place? Why don't we have staff standing there with their mobile phone, with a staff app on it? You've bought probably your own mobile. You've got a QR code or NFC or whatever else. And you walk up, having purchased your ticket, and you go blip on their phone. And they say yes, and you walk in. Confused. A little booth, nothing like that. Okay, maybe you've brought somebody with you who doesn't have a ticket. Why can't that same person with that phone app say, okay, I want to buy another ticket? And they go, yeah, sure, no problem. Either when I see it in the card or they've got a reader or whatever else, you just buy a ticket, you're in. Just like that. No problem at all. That's the dream which TicketSure was about. Area 360, our client, wanted to do exactly what I'm talking about, and what we call a TicketSure. And they came to us in mid to late last year and said, look, we've got this great idea. And more than that, we've got an actual system. We've got a PHP app that actually does this. It's running with one of the largest museums in Los Angeles. It's pretty much our only client. And we want to take it to the next level. We want to make it API first. We want to make it software as a service. We want to make it so that we can handle 100 clients, 1,000 clients doing this. To really redefine ticketing properly the way it's supposed to be done right now. The way we've been doing this queuing thing for 100 years. Let's just not do that anymore. Let's actually make this modern. Let's make this current. And so we said, yeah, sure. They let almost 12 weeks to do this, do or die. You know, almost like brownfield, greenfield. Let's redo the entire thing in this PHP app. And we go, all right, we'll take a look. So what we ended up doing for them, and we actually made it, by the way, we made it in 12 weeks, was to take the guts out of the PHP app, right? A very fast API backend in Golang. We're an Amazon consultancy as API talent, so we're keeping up within the Amazon infrastructure, which is great for all the high availabilities and stuff and everything else. Kept the MySQL in the backend because we want to move to Aurora when it gets big enough. All the AWS stuff, and this worked really, really well. This was fantastic. And this was the core of my presentation at the AWS Summit. And I'm not really going to talk about it because there's probably a few of you were there. We ran into issues and problems actually making this in the first place, making an API of that sort of size and that sort of complexity, specifically with that sort of time scale. And even though we won, I really want to kind of get up and say that making these things kind of isn't easy, especially if you really want to go microservices, if you want to do it right. And that was kind of the thing, because we ended up writing something that looked a bit like a monolith. And I got up on stage at the summit and basically asked people to rethink their assumptions about monoliths and microservices. And I didn't really get this across properly, I don't think, because a few people kind of tweeted and called me afterwards and said, okay, well, basically you're saying let's make monoliths great again, let's do this. And I'm like, okay, now hold on. That's not right. But there are issues with microservice architecture. And that's not a popular thing to say. So let's maybe take a look at them, let's go over them. There's the compound latency problem. Now this is essentially whenever you've broken up your system into lots and lots of little services, and the services kind of call each other, and it's all great, they're all scaling individually, and you get all the real benefits, that sort of stuff. The thing is that because they're calling each other, because they're kind of calling in chains, you're tied to the compound latency of that train of calls. More about that later on, but that's one of the issues in the first place. The second one is that in any system, any distributed system where you're breaking sort of stuff up, you end up with distributed state as a matter of course. You end up with transactions, distributed transactions across your services. And no matter how well you architect it, even if you've been very, very clever, there's kind of no way around that. At a certain level of complexity, you need something like a DTC, a distributed transaction coordinator, something like that. The third problem is that in all systems like this, you're going to have something which needs done, which kind of needs to be idempotent. And usually it's a maintenance task or database upgrade, something like that. But you need to have all of these little services, and one particular class of them needs to decide that one service needs to do one thing exactly once. And to do that properly, you kind of need to implement something like quorum. You need to have them come together and vote on one instance to do this. The thing is that these are some of the problems with the microservices approach. It's kind of funny because back in the real old school stuff, we didn't really have these issues. Whenever microservices came about in the first place, it was even, I mean, this is Stefan Tilkov, one of the ThoughtWorks guys, saying, you know, you may not actually need it. You may not need to go all the way down this whole microservice way of thinking. If you can build a really well-structured monolith, then why bother in the first place? Why just avoid all this complexity? And that is actually a paraphrase quote from Martin Fowler. Here's the thing, I'm kind of bored of this argument. Monoliths, microservices, all of this sort of stuff. For me, this is actually a symptom of a much more generic problem in software engineering, software design, software architecture overall. And I call it the granularity problem. It exists at every level, architecture, software design, all the way down to individual classes, individual sets of functions. And this is, how big or small do you make a particular functional unit, using a very broad definition of functional unit. So let's just remind ourselves. This is actually from one of Fowler's original posts. Microservices versus monoliths. We take all of the little kind of functional groups within a system, and if we pack them all into one particular application, one monolith, one thing on its own, then you call that kind of a monolith, and you scale it by having many, many copies of them. Whereas in the microservices approach, you break these functional units up as intelligently as you can, and you scale them individually. Now, that gives you massive advantages, and it's definitely cheaper if you're going down the whole like plateaus sort of thing. These instances can be smaller because they represent less functionality. The thing is that it's really, really, really easy to get this wrong. It's really easy to get this wrong, and there's a couple of different ways you can do it. Getting it wrong, I mean. Entity services. Now, this is kind of, everyone's seen this in like one-on-one comp sci. You know, it's the kind of really naive approach about how you do SOA and micro-SOA, and this goes way back. It starts with something like this. You have a relational diagram, and this is how you're modeling your entire system. So for this one, we have users table, we have roles table, applications, permissions table. This is kind of like a basic auth system, right? And if you do it in this particular way to get it wrong, if you're naive about it, you end up with something like this. You end up with a set of services, one service representing each entity, normally with a different database behind each. And let's just like kind of run over the problems here. There's no referential integrity between these. They're not even on the same database. You're going to have something like a DTC to modify it at all in any way. It just gets kind of problematic in that sort of way. You can see how this is a naive approach in terms of that. You can take an entity as being the core modeling like functional unit of the entire system, and we just wrap services around that, that's the end of it. On the other side of the scale, you end up with microliths, which is where you say, okay, I've got this application, I'm going to plumb it in with a database, and we're going to call that microservice. And we're going to have 100 of it, it'll be great, no problem. And then there's kind of the third path, which is where you haven't gone down maybe the entity way quite so much, but you've actually kind of gone one step further than that. And this is especially common in some modern languages, some modern functional languages, nanoservices. Now, if you haven't heard the term before, this is Arnold tells us about nanoservices, where a nanoservice is not a pattern, where a service is too fine-grained, where a nanoservice is a service whose overhead outweighs its utility. What does that remind you of from a couple of slides ago? Because funny enough, that's actually what tends to happen. You end up with these tiny little functional groups, usually individual, and this is driven worst from user stories, where people go, okay, we need to do this, then do this, then do this. So we write a service around each one, and they all kind of talk to each other. And usually you end up with something like entity services below it, and these things all communicate. These things are going over network links. Depending on the language, depending on the implementation, you can end up with serious latency between these. The compound latency problem in this is a nightmare. Not to mention the fact that even though all of these kind of functions here loosely could be said to be part of an authentication system, they're actually all different services on their own, which means the deployment's a nightmare, the development's a nightmare. I'm not going to get into Conway's law in terms of how this is actually developed in the first place and deployed. But you end up with all of these problems. The compound latency is frankly the least of your problems, and it's still serious. The thing is, this is slow. Even if you get it right, even if you kind of, get it right as much as you can within this sort of model, this is going to cost you a serious amount of time for an API call because you're running through lots and lots and lots of little individual services. And the truth is, this is 2016. Speed wins. People will tolerate your API if it doesn't always get everything exactly right, if the data's maybe a little bit old, if the cache's too long, that sort of stuff. They will not tolerate it if it's slow. They will walk away and they will never come back. The thing is, with all of these sort of things, and especially with the speed problem, it's kind of funny because we're talking across purposes. You've got in-system versus in-process latency. Now, take a look at our example again. This is the nanoservice kind of approach. This is the anti-pattern. And those low latencies maybe not even under load across networks. And let's not even talk about multi-region. Let's talk about multi-availability zone, even within the same data center. You may see latencies like this. But what if, and here's the thing, what if we kind of throw away the whole idea of these things talking to each other over a network? What if we maintain the isolation for these particular functional groups, and even, to be honest, down to the entity systems? And we say, these things aren't put together in system. Let's put them together in process. And suddenly it's just like this, where we have these little functional groups, call them classes, types, but choose your paradigm within your language. And they talk to each other in process, where the entity controllers, or that access layers, or ORM components, or whatever you want to call them, are actually kind of sitting there isolated on their own. Now, this just looks like one-on-one software engineering, right? But I'm taking it a little bit further than that. I'm saying that maybe there's nothing wrong with these things kind of behaving like tiny little services. As long as they're communicating with the sort of latencies that you see out here, as long as they're communicating either in process or at least in a shared memory model. The idea being that the communication between them is very, very fast. Not to mention the fact that you can tie it down to, maybe you've done the approach before where you have lots of different databases where there's no relational integrity between them, that sort of stuff. You can get around some of the DTC problems by saying, right, well, maybe we talk to 1 or 2 or 3 large databases which scale independently. Maybe we handle our quorum problem by using something like SQS or RabbitMQ or one of the other open source queuing systems to actually handle this idea where we have a task which is put onto the queue, which then is developed by exactly one instance and made it to happen. Maybe that's how we do that bit. But why would you bother? This just looks like writing a monolith, right? Why would you bother to break up these little bits into small services to make up a microservice in the first place? And my argument is that maybe the reason why you want to do that is because then you can do something like this. You can say, okay, well, you know what? We want something which is more individually scalable. We want something which generates sort of smaller output, something which is more manageable. Maybe we have teams, let's go inverse Conway and say that we actually have 2 teams that want to manage 2 different parts of this, want to develop 2 different parts of this with different domain experience. Okay, having written a monolith, you see what I did there? Like that, we can actually break it up. We can say, what about we have these small services that are composing microservices? And then, later on if we need to, because we've written it that way in the first place, we can actually break them up into something which is more like two services, like microservices. Why not? This is kind of the inverse of I'm going to paraphrase a quote by Sam Newman, which was all about how it is so much easier to take an existing system and break it up. Now, experience may say otherwise, but remember the first time you implemented a microservice architecture from scratch, complete greenfield. Generally speaking, if you didn't do it in one of these ways before, you end up changing the boundaries of the services halfway through the go. You end up re-architecting, you end up rewriting a lot of stuff, because at the start, you didn't know where the separation of concerns was. And there's no way you could have. You had to develop it, you had to go through it. This isn't waterfall, there's no creationism here, you know? You work through it, and you learn. And this is maybe one of the ways of pitching, in which if you write something like a monolith in the first place using this very small service approach, then you can break it up more easily later on. Now, certain things, certain languages, certain platforms lend themselves to this more than others. This is where I can stand on my soapbox and say about Golang, because Golang is awesome for doing this sort of thing. You have inbuilt concurrency in the language. You have Go routines save channels, pipes between these things. You can build these little tiny services in their own Go routines. And you can have, Go routines are not like threads or more like self-scheduling fibers. You can have 100,000 of them in the same process with virtually no overhead. It really is absolutely beautiful. As I was reminded of the meetup on Tuesday, you could do the same thing with Erlang, you can do the same thing with a lot of different languages. It's just a question of thinking about the separation in the first place and maintaining that isolation within the same process until you need to break it up later on. To come back to that, you end up with something like this. In Golang, you'd have Go routines representing these little individual functions. Maybe those are too fine-grained right now, but we can merge them and change them later on. We have channels communicating between these, and something like I've merged users and applications here, because maybe that's an easier way to represent that relational data talking to the database. But because of this channel system, it's reasonably easy to throw data across maybe a network link later on whenever you want to break it up into two services. And that can work reasonably well. Really, the takeaway here overall is that this argument between monoliths and microservices, and there's been a massive reflux in terms of people talking about, no, hold on, maybe we shouldn't do microservices at all, which was not what I was supporting. I'm saying that the granularity issue, the microservice versus monolith argument, is a symptom of the granularity issue. And really, we should be thinking about granularity all the way from the top to the bottom, all the way from the architecture, all the way down to the individual implementation of even certain types. In 2017, let's just end the holy war that's kind of starting and restarting and say, let's rethink our assumptions on granularity. Thank you very much. I'm not going to take questions, but if you would like to tell me I'm full of crap about all this sort of stuff later on, then please find me in the break and please do. And thank you.